So again, trig identities are going to be something that we focus on more in a later chapter, but we have a little taste of it. Okay, so let's recall some things from an earlier video. So let's remember that the tangent of an angle, we're using theta here, we've used t before, is the same as the sine of that angle divided by the cosine of angle. And that's true for any angle as long as cosine of theta is not equal to 0. So that's our only requirement for this thing to be true. Okay? And then the same thing is true with reciprocal functions. All right? Remember also reciprocal functions are just one divided by the other function. So we have some other properties, some other identities that we've used as well. This one over here. The sine squared of any angle plus the cosine squared of any angle is equal to 1. This is the Pythagorean identity. And again, remember that sine squared of an angle just means the sine of that angle squared. We have enough parentheses without adding more. Just watch out for that. Boop, boop. Okay, well, there's two more variations. One Pythagorean identity wasn't enough. We got two more for you, all right? There's two more Pythagorean identities. You don't have to memorize them because of this one simple trick. Doctors hate them. Okay? I'm working on my clickbait, my mathematical clickbait. So let's leave them for later. Let's do example 5, which is completely unrelated. All right? So what happens to the Pythagorean identity? What happens to number 1 if we divide both sides by cosine squared of theta? Well, I don't know. Let's find out. So if we divide everything by cosine squared of theta, this is what we get. Sine squared of theta divided by cosine squared of theta plus cosine squared of theta divided by cosine squared of theta. Oh, I like that one. Equals 1 divided by cosine squared of theta. Let's unpack all of this. Let's start with the one I really like in the middle. This is the same thing as what's below it. Anything divided by itself cancels to 1. Ooh, that's nice. And look at the right-hand side, right? 1 over cosine squared of theta, that's the same as 1 over cosine of theta squared. But notice that we could also write that as like this. These are the same thing because 1 squared is just still 1. Well, what's the reciprocal of cosine? We have a word for that. The reciprocal of cosine is secant. This actually becomes secant squared of theta. And with a similar logic, sine over cosine is tangent. Square everything, we can get that tangent squared of theta. So this is Pythagorean identity, part 2. New identity. Wow, how fun. Tangent squared of theta plus 1 equals secant squared of theta. And you can also do the exact same thing by dividing everything by sine. And if you divide everything by sine squared of theta, you're going to get 1 plus cotangent squared of theta equals cosecant squared of theta. Okay, right? If you divide everything by sine squared, this cancels. Cosine over sine becomes cotangent. 1 over sine becomes cosecant. And that's where these other ones go. So these right here are the 3 forms of the Pythagorean identity. And again, everything is open book in this class anyway, so you can use your notes. Or you can just remember sine squared plus cosine squared equals 1, and then do this exact process. Either divide by cosine or divide by sine. Because I'm going to be honest with you, I always forget this one. I literally forgot it when recording this video. But I just knew we divided by sine squared, and this is what we have. Okay? Anyway, Those are the identities. Let's use them a little bit with an example. With two examples. Nope, with one example. With two parts, a duology. What's a good movie that's only two? This is why I need students. All right, you can answer these important questions in the middle of class. Example 6. Simplify. Part A. Secant of t divided by the tangent of t. So usually when we're doing this, and again, we're going to spend a lot more time on this in a future chapter, usually it's a good tip to put, well, I'm not going to put that tip yet. Well, I don't want to spoil it for you. That'll be in a future section. All right. But a lot of times it can be a good idea to put things in terms of sines and cosines. But at the very least, we want to get rid of reciprocal functions. So what is secant? Secant's 1 over cosine. Okay. So secant, let's replace that with 1 over cosine. You know what? I will write it down. I will write it down. Often good to get rid of reciprocal functions. We have 1 over cosine. Well, if we could have something with cosine here, maybe things would simplify. Well, tangent is related to cosine because tangent is sine over cosine. So now we have got cosines, and maybe these cosines are going to interact. We have fractions divided by fractions. That's the numerator fraction divided by the denominator fraction. And dividing fractions is the same as multiplying by the reciprocal. So let's multiply by the reciprocal, and by golly, we got some cancellation on our hands. We're just left with 1 over sine t. And we have a special name for that. That's the cosecant. So secant over tangent is actually just the same thing as cosecant. And again, this is just a little taste of something we're going to be doing a lot more later on. Last problem is more of a doozy, but it's a fun little thing. Cosine of t, we want to simplify this, divided by cotangent squared of t plus 1. So you can put everything in terms of sines and cosines. There's a couple of ways actually of approaching this problem. But what we're going to do is use an identity. That denominator looks awfully familiar. Cotangent squared plus 1 is the same as cosecant. Right? Cotangent squared plus 1 is just cosecant squared. So if these things are the same, we can replace them. Okay, let's underline this one. These are the same. So just replace. The top doesn't get changed, but the two red things are the same, so let's replace one with the other. And now let's get rid of that reciprocal function. Okay, so the numerator stays the same. What's the denominator? Cosecant is 1 over sine, and it's cosecant squared. Now let's do what we did in the last one. Cosine divided by that denominator is the same as multiplying by the reciprocal. Well, the denominator is 1. We don't even have to write that denominator. We just have sine squared of t times cosine of t. And that's as simple as it's going to get. There actually is kind of a cool thing that we can do that we will do later by replacing sine squared using a variation of another identity. But again, I don't want to jump ahead of myself. This is really good. This is good and simple. So these ones are more complicated for sure. And this is going to be more of a focus in a later chapter. So, you're exposed to it a little bit here. But we're really not going to be doing much with this until later on. Just a nice little taste. get you to start salivating for math. I need to stop the video before I keep talking. Bye-bye.